Hello, welcome back to the Open Polkadot Bootcamp. Today we're gonna learn about a very interesting topic about a sharded network of the Polkadot. We don't see any code, but we just use the visualization that I draw a few months ago to learn about the Polkadot network, and how it's the overall flow of how the new block can be added to the relay change from the Parachain. This section is necessary to provide you a fundamental knowledge, everything that you need to know about the Parachain and also the relay change before you move to the Cumulus, using the Cumulus library to build a Parachain in Polkadot SDK. And now we're gonna move to the visualizations. Here's the visualization that I draw a few months ago. It's quite heavy. You see there's a lot of information here, and it's not easy to consume all these, but we're gonna try to go step by step. So we already learned that the relay chain is a model chain of the whole network, and this relay chain have a few other node. This node help to operate the relay chain and keep the relay chain running distributedly. The relay chain offer the whole protocol a shared security feature, a native shared security feature. Why is a shared security? We're gonna learn later as well. So the relay chain is here. Then the relay chain have a few different core. These core are core execution core. And in a relay chain, the relay chain is also have a shared ledger. It's a distributed ledger of the relay chain. Each parachain also have its own distributed ledger, but for the distributed ledger of a modern network, then that one. The ray block right here to indicate the past block, and this one right here is the new block added from the parachain. So the flow gonna be we're gonna learn how the parachain can process and produce finalize the new block, collate that to the relay chain, and then how this block can be added to the pipeline of the relay chain. So we have this node, and before we go to the consensus mechanisms, we're gonna learn about this execution core a bit. So why the execution core is important? So this one is the Polkadot host implementer of this one is the Polkadot host implementer, and the Polkadot host implementer is in the component of the Polkadot host implementer is one of them is the availability core. This availability core is similar to the core in the CPU. They are scheduled in the round robin style, similar to the CPU cores, and operate in the time slot. The core is the base unit of the parachain. The base unit of the parachain is not a parachain itself, but an availability core or the parachain slot. So under the parachain would be the execution core, availability core, what you say. The parachain gonna be assigned to this core. So for this protocol core allocations, then you have Azure core times and also on-demand core times. Before if you want your parachain to use the Polkadot feature, become a parachain, you want your blockchain to become a parachain, you have to register and then participate in the parachain ocean to acquire a 2-year lease. This one gonna be the candlestick oceans, and all the parachain have to participate to that process to receive this 2-year lease. So when you already receive win the parachain ocean, receive the 2-year lease, then you can rent the core for 2 years, and then later you can renew. So you don't have to pay for the cost of the core monthly, but only at the time that you win the core. So when you already win the core, you don't have to pay for it anymore. For the parachain, it simply just be compiled to WebAssembly block, and it assigned to the core itself on the relay chain for the execution. And the execution core allow Polkadot to provide a block space as a service and are designed to work with any Web2 applications. So you can imagine in our personal laptop, personal computer, we have like 64 or 32 cores on the personal computer, right? And those cores, whenever you run any applications, so the process of the application gonna like occupy the core to process the operation of the applications. For example, right now, like when I record these videos, multiple cores in my laptop is also like occupied by the program, by the software that I'm using to record the videos, and also like to connect with the mic and process like the data that I send to the mic. That's how it works. So for the applications on Polkadot, imagine like this one is also similar to the CPU. Parachain gonna be like on the application level. This core gonna be on the kernel level, kernel LAN. Okay, so we're gonna keep this core section later, not for now. And now we move back to the relay change. So our Parachain over here, as we already learned, let's have the node and the runtime. Node, runtime, palette, on-chain storage. If you haven't, watched that video yet about the architecture of the Parachain, of the blockchain on, using Substrate and Polkadot SDK, please revisit it to understand what is the runtime, what is the palette, and also like how the node service runtime API. Yeah, all those already like covered in the past videos. And this node in the Parachain is also participate in the node discovery mechanisms that allow it to use like libp2p to communicate with other blockchain in the same network. The consensus mechanism of a Parachain and the consensus mechanism of a relay chain are two different mechanisms. Reason for that will be explained to like when we work through the process of the diagram. For the Parachain, the consensus mechanism used in the Parachain is proof of authority. What does proof of authority mean? Is like there's a list of trusted authority. This trusted authority will be ingested by the pseudo key. Remember, this pseudo is like what we already learned in the palette module. These trusted authority are basically the node that configured to participate in the Parachain network. When we already have the list of trusted authorities, the algorithm to select the next authority will be run. This algorithm based on the round robin style. And why does it mean round robin style? Because like to select the next index of the authority, the remainder of this operation slot mode, the authority length will be run, and when you got the index, that authority will be selected and then participate to produce block. To explain this operation, so when it's run to when it's go to the new slot with the same authority length, then a new authority will be definitely run in. So let's say if you have 10 authorities in the vector, current slot gonna select like authority 1. When it's moved to the slot 2, then the authority index 2 gonna be definitely picked. Move to slot 3, authority 3 will be definitely picked. And when the slot is more than the authority length, it's gonna run again like a cycle, like 1 2 3, then like come back like to 1 2 3, and then come back to 1 2 3. So it's participate to this process of block production. So when it's produced a new block, this para block goes to the block inclusion pipeline. The para block is a block produced by a Parachain. Go to the block inclusion pipeline. We're gonna learn about block production or block inclusion pipeline later. And as you can see, like this is Aura, like block round robin style block production mechanisms. Aura is also like used in the sovereign blockchain, which is not like connect to the Polkadot network, doesn't connect to the relay chain or solo chain. A sovereign blockchain, however, like also have a block finality gadget with RenPar, because like you want to have a new produced block to be added to the shared distributed ledger of the solo chain, right? And in that way, you need to have a finality gadget. If you only like produce block and you don't finalize block, then that means like your blockchain database doesn't update it. Here we also have a fork choice rule. So how the fork choice rule work? The block productions on the Parachain level is forkless because there is only the one authority produced block at a time, following the latest included para block. Because like there's no block finalization happen, and it's only like select like one authority at a time. So this block production mechanism is quite simple and it's on very secure because there's no way that the like malicious action can happen. This authority already been adjusted, So that's mean like there's a level of centralizations right here. But most of the time that your parachain is only have a few nodes that participate to the collation process. By default, this is very simple and doesn't bring much security risk. However, like there's also like a few other cases that you want to customize your blockchain to use like other mechanisms as well. For example, like in Moonbeam blockchain, like in EVM compatible layer blockchain for in Polkadot, and Moonbeam use a different consensus mechanism called delegated proof stake. Now we go to the core part of the block inclusion pipeline, how the par block can be added to the relay chain. In the Parachain, we expose the two nodes to participate into the collator as a collator, and in the relay chain, it's gonna have the assigned validator set, or we can call it Parachain validators. The Parachain node and the Parachain validators mix between the current active validator set with the collators of the Parachain. These all combined together become like one set. The collator, after they produce the block that we have here, after we produce a block and this goes to the block collations, this collator will send the finalized block and read by the 2/3 of the authority set we have in the consensus on the block productions mechanisms of the local relay change of the local parachain. Is sent to the collation process at the stage 1 of the block inclusion pipeline. Collation is simply like just gathering the block and sending to like other entity. So this collation process basically collect data for the para block. So all the data needed to check the transitions from the various parachain state to the current state. Deep dive into the collation process. All the transactions will be like collected by the collators. These transactions will be like compiled together and become a candidate, or we can also call it a parachain block. This candidate contains a few different components. First is the receipt, and the second one is the POV or proof of validity. The proof of validity include the final headers of the parachain and the state transition data. What is the state transition data? The state transition data is all the data needed to check the transitions from the various parachain state to the current state of the parachain. The state transition data has like the list of applied extrinsics, and we already learned like extrinsic is like when you submit a dispatchable functions, it's gonna generate the extrinsics, and those extrinsics change the state of the parachain from state A to state B. And there's also a Merkle node have in the state transition data, and we study that in the storage abstractions sections that above the database layer there's a Merkle tree. The Merkle tree has a proof of the state transitions, or we can also like call it state proof. And the Merkle node going to be also added in the state transition data. For the receipt, there's also a few data structure added here. The first one going to be the candidate commitment and the candidate descriptor. We don't have to understand like, what are these like candidate commitment and candidate descriptor, but just imagine like this candidate or parachain block already have all the information needed about the state transition data of the parachain, or we call it POV. Now, what happened after like we already like collect and also like process this candidate? We're gonna submit this candidate to the Parachain validator, and this Parachain validator gonna be assigned to the validator set of the relay chain. So as you can see, like this process happened here. The node as the collator gonna send to the like process the collations at the stage 1 of the block inclusion pipeline. Similar to the state transition function, so this Parachain validation function is responsible for validating the Parachain proof of validity. After processing that, the PVF gonna generate a packing statement and got shipped to the 2/3 of the packing group about this packing statement. And it's also like verify and select the candidate and packable by and packing that candidate to generate another like packable candidate data structure. This packing process is also one of the important part in Polkadot, where we have like synchronous packing and asynchronous packing. What is synchronous packing and asynchronous packing? So for the synchronous packing, the pipeline of packing the candidate gonna be go up to like 10 seconds, because this cannot happen at the same time, but it have to happen sequentially. So as you can see, like at R0, R1 and R2, the packing gonna happen in between like R0 and R1. then the inclusion gonna happen in R1 and R2. Then if you want to include another block, it's also like need to happen after the inclusion of the first block. And this is not like very ideal because now like everything is happening synchronously. Like the block 2 have to rely on the block 1 for the block 1 to be included first before the block 2 need to be included. So what does asynchronous backing bring to us? That means that asynchronous backing reduce the time for the block inclusion pipeline of the P1 to 6 seconds instead of 12 seconds. Why there's a backing process happening and the inclusion happen here, then there's also another backing process can also happen at the same time of the block 1. Then later on, like when the inclusion pipeline when the inclusion of the P1 finish, the inclusion of the P2 is already get started. Instead of like compared to this one, that like when the inclusion of the P1 started, the backing is just get started, not inclusion. Since that way, like it need more time to backing and the inclusion and the backing inclusion. So this technique right here in computer science is so called pipelining. Now we'll go back to this backable candidate. After go to the backing process, we have like the Parachain inherent data. I forgot to mention, but this stage is called backing. So everything gonna happen to like the backing the candidate. Where it's become a Parachain inherent data included by Parachain validator. The candidate receipt or the head data gonna be added to the Parachain block. Then this Parachain block gonna be occupied on like gonna occupy the Parachain one, gonna be occupied by one Parachain core. After the state backing would be the state availability. After the backing stage, there would be the availability stage. This availability stage process all the things happen related to the data availability between the Parachain and the relay chain. So data availability is a very important problem in distributed system and also in blockchain in specific. In Ethereum, like we have like proto-dank sharding or like full-dank sharding or like data availability sampling are some of like the Ethereum proposal that you can reference related to like data availability. In Polkadot, like this data availability are the inside availability layer. So the availability layer of Polkadot is necessarily happen for the validator to make sure that the data are available on the Parachain. When the validator of the relation receive this Parachain inherent or Parachain block, it must like verify that these data are available on the Parachain. And as you can see, this stage like checking the availability of the candidate in the block is happening on like one Parachain core. The Parachain core gonna fetch chunk of eraser encoded POV. This eraser encoded is a data correction technique that allow you to add some extra data to the original data, and then later on when you only like have like 50% of the original data, you can recover it back. So after like having fetch chunk of eraser encoded POV, the validator can recover it back because it's eraser encoding, right? So it can like recover the full data of the POV back, candidate recovery using large enough chunk, and then you have like the full POV data. Then later on, like the validator gonna send these to the 2/3 of the relation validator, and this process gonna be like happen on the Parachain core. So like any large enough subset of chunk can recover the full data. This provide protection against like node that go offline or lie about like having the piece of data. After the availability stage, they're gonna be like the approval checking and dispute. So approval checking is basically if it's approved, then it's gonna be included to the relay change, and if not, then you're gonna move to the state 4 dispute. You dispute that like, okay, so this is wrong and I don't want to include that. For the approval checking, we're gonna provide like a list of validators. This list of validator is the list of like assigned validator set we already have before. Every validator node is running approval checking processes for a random subset of Parachain block in every relation block. If the initially assigned approver for a para block no so, then we assume like an attack and in the worst case escalate to have the entire validator set check the block. So we pick like a random validator, and then if there's some malicious action, we're gonna ask like a whole validator set to check that block. It's gonna happen to the Parachain team fault process, and if we file a malicious validator, good validator gonna dispute to kick this validator out. This called slashing in nominated root of stack, or basically in root of stack itself. So when someone dispute the validity of the para block, All validators must then check the block and cast a vote. The validator on the losing side of the dispute are slash, and that is how the block is included into the Parachain, and this is called a part of the Parablock. There's also a blog post on Polkadot.com about that, so you can read more. So what happened after you have a block included to the next block of the relay change? So what does nominated root stack works? Nominated root stack gonna happen to different on a few different stages. The first one gonna be validator elections, then nominations, and then hybrid consensus. All the stack validator, all the validator who stack to participate in the Polkadot network gonna become the candidate. Then from these candidate, there's a computations of fragment algorithms. This is gonna happen off change, because if you have a millions of validator participate stack to your network want to become the elected validator, then it's not ideal to process or 1 million validators or 1 million voter on a runtime. So you need these computations of fragment algorithms happen off chain, and it's gonna be on the off chain worker that we already mentioned in the hook sections. And after these computations, we don't have the set of winner. And when you have the set of winner, this means you have the set of elected validators. These elected validators will be nominated by the nominators of the nomination pool. So the nomination pool gonna nominate who gonna validate the block. This is another just indications gonna happen here that the nominator have to just the validator to participate in the block productions. When we have the active validator set, this set gonna change every y amount of hours. And we also have right here run on every epoch. We have different unit slot, epoch, section error. Slot gonna be the smallest unit. So the slot equal to the 6 seconds. The epoch gonna be 4 hours. One epoch equal to 2,400 slot. Section gonna also be 4 hours. 2,400 slot as well. For the error, it's gonna be 6 epoch equal to 14,400 slots. Why this is important? Because that's mean for every 4 hours, the new elected validators are gonna be chosen again, and also choose them from the nomination pool again for the active validator set. This is gonna happen after 4 hours. So sometimes one nominated validator can be picked to produce the next blocks. Sometimes it doesn't. But for the algorithms of what Polkadot design, and I don't have the time to talk about it here. It's gonna ensure that all the reward gonna be distributed equally to all the stack validator. So we have the BAPE. BAPE is applied assignment of blockchain extensions. This is a block production mechanisms. For the BAPE, how this work is it works similar to the lottery mechanisms. So you're gonna go to verifiable random functions (VRF). Just imagine this RNG, random number generator. That it run and then select what is the random number here. This random number indicate the index of the validator in the active validator set. After go to this engine of BAPE engine, then you can select the validator, and that validator can participate to produce a new block. When it produces a new block, it has to go to the another gadget called finality gadget. RenPar stand for ghost-based recursive ancestor deriving prefix agreement. This is some crazy term that they spend a lot of time to research about this. But simply RenPar, they also have this voting process: propose, revote, recommit, commit, and then finalization rule to add that block to the finalized block. And then just imagine you have the BAPE to produce a new block. Choose who will produce a new block. RenPar finalize the block. That's all. Pick what is the best chain that it's gonna follow. Then it's gonna submit the rule of finality to the finalized block, and then you have it here. So the relay chain block include the basic data of the blockchain block, intrinsic inherent data on the relay chain level, and the Parachain block data. And you can see that is the whole part of the block, and how that can be produced from the Parachain and added to the relay chain. and that's a very complex process, and they spend a lot of time to design this system. And that's also the end of this today video. Thank you, and hope that it's gonna help you to understand how the sharding network of Polkadot works under the hood.